Let's talk about this new kind of coordinates, spherical coordinates. So we're describing things in R3, so we need three coordinates, but we have three different coordinates. These are going to be able to describe the same points in space that we did with rectangular and cylindrical coordinates, but we're going about it in a different way. Notice that we didn't include our old ones. So there's no X, Y, and Z, there's no R. Theta still seems the same. And then phi, we got two new coordinates here. Now, in the spirit of categorizing them, excuse me, in the spirit of categorizing them like we did before, rho is going to be a length, but theta is an angle, and phi is also an angle. Rho is a length, but theta is an angle, and phi is an angle. So when we go to calculate the dV, some piece of volume, d rho is a length, so that's cool. D rho is a length. We're going to need something to turn d theta into a length. So I need something times d theta to make an arc length here. Notice that we don't have the same r that we had before. So that d theta, we're going to have to find something else to be a coefficient of the d theta to turn that angle into an arc length. Phi is also an angle. So I'm going to need another factor to turn d phi into an arc length. So I need something to turn phi into an arc length, and I'm going to need some other factor to turn theta into an arc length. And it's going to depend, both of those things are going to have to depend on rho, because the arc length is determined by how far we go away from the origin. So whatever these factors are, these question mark factors will be functions of rho, because distance is what turns angle into arc length. It's distance that turns angle into arc length. So before we can do that, we have to describe how spherical coordinates work. But I wanted to show you the basis for what we're going to be doing and what we want to do with spherical coordinates in this scenario. I need to make a dV, a small piece of volume. I need that to be the product of length times a width times a height. So the d rho is a length, but d theta and d phi are angles. So I need some factor based on length to turn those angles into arc lengths. Any questions? Comments? Snide remark? Well, let's talk about how rho, theta, and phi describe a point in space. So I'm going to draw an x, y, and z axis, because these are all just sitting on top of each other. So I'm going to have, let's say, an x that traditionally comes straight out the board, a y, and a z-axis. And we want to describe a point in space. Let's see, what's going to give me enough room? So let's suppose we want to describe this point. So that point is rho, theta, phi. Let's give ourselves some basis for where we are. So let's suppose that this is sitting above a point in the xy plane. So that rho theta phi is sitting above the xy plane. So let's talk about how we're going to describe this point. Now, if this is x and this is y and this height is z, then we would just call that xyz. If we look at this point here, we have r is going to be the distance from the origin to the point directly beneath the, I should have named the point, directly beneath this point, the point in the xy plane directly beneath the point in question, and then we'd measure theta as an angle up to where we draw r. That sentence came out terrible. Maybe I should really start working from a script. Oh well, glad that got recorded. So one of these needs to be a length, and there's only one way to measure length that makes sense. This is why we couldn't use r anymore. We had to use rho, because we don't have another length to say how high above the xy plane should we go. So rho is the distance from the point to the origin. There's only one choice. If there's only one choice, then you actually don't have a choice. So I went full Elrond. Rho is the distance from the point to the origin. And it's coming off at some wacky angle. Theta is the same theta that we had in cylindrical and polar coordinates. So if we project this point down to the xy plane, theta, yeah, theta is the green one. Theta is the angle in the xy plane between the positive x-axis and a line directly under the point. Theta. Theta is the same theta that we were using in cylindrical coordinates. The new one is phi. Phi is the angle between a line connecting the point to the origin and the positive z-axis. So theta is measured from the positive x-axis. Phi is measured from the positive z-axis. Oops, I wrote the wrong, spelled it wrong. Phi is the angle measured from the positive z-axis to the point. I wrote phi wrong. I can't write phi today, apparently. So rho is the distance from the origin to the point. Theta is the same theta we had in cylindrical coordinates. It's the angle from the positive x-axis to a projection of the point in the xy plane. And phi is the angle from the positive z-axis to the point. Any questions? How's everybody okay? Everybody looks stunned. mostly because it's just like a bunch of names, and so they don't have expressions. So if right now you're like, oh, this is confusing and I don't like it, that is the correct answer, because this is just a new way of measuring points in space. We're not doing a new thing, we're just describing it in a different way. So what we're doing is listening to something that we're familiar with, but in a foreign language. And we're just trying to put those things together. So if you're anywhere between slightly confused and super confused, that is the correct answer. It'd be ridiculous. I mean, math, there wouldn't be a whole thing about how to learn how to teach math if all I had to do was say things once and everybody's like, oh, yep, got it. That would be just like one step away from plugging ourselves into the matrix and having Tank download some programs into our heads. Any questions? All right. So rho is the distance from the origin to the point. That's the only thing that indicates any length. So that's the only length that we could possibly use. Theta is the same theta we had in cylindrical coordinates, measured from the positive x-axis. And phi is the angle measured from the positive z-axis to the point. How's everybody, okay? So we need to figure out what these factors, we need to figure out factors which should both be functions of rho to turn these angles, d theta and d phi, into arc lengths. Everybody see what our goal is? It's hard to picture the coordinates of the point because we've only seen them described once. But we also want to keep in mind the thing that we're trying to do. We're trying to find lengths to turn angles into arc lengths. We're trying to find some radii to turn these angles, d theta and d phi, into arc lengths. Let's take a minute and plot a point and then figure out what those rows should be. So let's suppose, let's see, I'll keep this on in view. Let's suppose that I want to plot a point, or I want coordinates of a point. Let's suppose I have this point, and it's 5 units from the origin. So here's the origin. This point is 5 units from the origin. So the distance from the origin is 5. What is, this is not going to fit. This point is 5 units from the origin. What is the angle theta that gives this point sitting on the x-axis? At that point on the x-axis, what is the angle theta measured from the positive x-axis to that point? 0. I wrote theta when I wanted to write 0 because theta and 0 have merged into one thing. The angle is, theta is 0 because that point is on the x-axis. What about the angle phi measured from the positive z-axis to the point? What is the angle phi? One suggestion for 0 and another suggestion for 90. Well, both viewpoints are equally valid, so it's both. Let's split the difference and call it 45. Oh wait, that's not how anything works. That's a terrible idea. There's a correct answer here. So we're measured from the angle from the positive z-axis down to the x-axis is 90 degrees. I'm going to write that in radians. It's fine to think 90, but you have to write pi over 2 because everything is radians. Go and use your degrees. Go ahead and use that in your physics classes. I understand they need everything to be divisible by a lot of things. But here in math, we like our irrational unit. I'm just kidding. It's actually very difficult because I have a class in trigonometry this semester as well. So I have to keep switching between degrees and radians. And it's making me crazy. For so long, I'm just like, all radians all the time. And then I'm like making fun of physics professors for being like, all degrees. I'm like, oh no, that's a terrible idea. I'm just kidding. It doesn't matter. It's just another way of saying things. Great. So 5, 0, pi over 2. It's really weird not calling this just 5, 0, 0. It's kind of weird calling this 5, 0, pi over 2. But pi over 2 is measured from the positive z-axis. What if I had a point here? I'm just going to follow this around in a circle. And this point is 5 units away from the origin. So that point is 5 as well. What is theta at the y-axis? So now I have a point on the y-axis. And what's theta? Theta is now 90 because we measure from the positive x-axis and swing out to that point in the xy plane, and that is 90, or pi over 2 radians. And what is the phi? Also pi over 2, because we're still in the xy plane. Everything in the xy plane is 90 degrees from the positive z-axis. So that point will be 5, and then pi over 2, and then pi over 2. This should be telling, we should note at this point that pi over 2 is the xy plane. Phi equals pi over 2 is the xy plane. Phi equals pi over 2 is the xy plane. Let me put a point on the z-axis. Let's take this and let's swing it up to the z-axis. And we're still 5 units away. What angle theta do I have to go through to get to the positive z-axis? So if I go 5 units away, if I swing pi over 2, and then what's phi going to be up here? Phi is going to be 0. So we got 5. If we go out to, if we go 5 units away in the positive x-axis, if we swing out to pi over 2, but then go 0 down from the z-axis, would that give us this point? This is the important one, right? Phi is 0. What are we going to do for this? Does 0 work? Because it looks like pi over 2 would work, right? Because at this point here, if I go 5 units away at pi over 2, that's on the y-axis. But then if z-axis is 0, if the phi, the angle from the positive z-axis is 0, that puts us on the z-axis. Let's see. If we do 0, go 5 units away, go 0, swing it 0 in the plane, but then z is still 0, or sorry, phi is still 0. They rhyme, so it's really giving me problems. I don't know if that's not enough coffee or too much coffee. Then what do we put in there? Doesn't that also give us this point? So we're like, oh heck, what's this coordinate? So the answer to this question, which when I answer it, will unlock all of the secrets for spherical coordinates, and you will instantly see things automatically in spherical coordinates all the time. And I have about, just right now, if I answer this question in this moment, then all those things will happen. It's almost like magic. So here it is. The coordinate here is, oh, look at the time. I guess we're gonna have to wait on that.